Today we define the alternating operator alt. It takes any multilinear function and cooks up an alternating one by averaging over all rearrangings with signs. A very civilized procedure, considering how much notation it is about to unleash. Start with a multilinear function t from v to the m into the field. We do not assume t is alternating. The goal is to manufacture from t a new multilinear function, called alt of t, which is alternating. So yes, we are building a machine whose entire personality is sign changes. To define alt, we need a sign for each rearranging sigma. A rearranging sigma of 1, 2, up to m reorders the input positions. If sigma can be built from an even number of swaps, we assign sign sigma equals 1. If it needs an odd number of swaps, we assign sign sigma equals -1. Yes, parity is back again, because mathematics found one good trick and never emotionally moved on. Now we can define alt of t. For inputs v1 through vm, alt of t is 1 over m factorial times the sum over all rearranging sigma of sign sigma times t. Evaluated at the rearranged inputs. I am using the normalized convention, because it behaves more politely. If t is already alternating, then alt of t will equal t exactly. When m equals 2, the formula becomes very familiar. Alt of t at u, v is 1/2 times t of u, v minus t of v, u. So alt keeps the antisymmetric part and discards the symmetric part. A brutally efficient editor. When m equals 3, the formula already looks more crowded. Because of course it does. There are 6 rearrangings in total, and each one appears with a plus or minus sign according to whether the rearranging is even or odd. This is the full antisymmetrization of t in 3 variables. Welcome to the part where the notation starts charging rent. First, alt of t is still multilinear. Every term in the sum is multilinear because t is multilinear. A sum of multilinear functions is multilinear, and multiplying by the scalar 1 over m factorial changes nothing. So at least that part behaves exactly as expected. A rare moment of cooperation. Next, alt of t is alternating. If you swap 2 neighboring inputs, every term in the sum gets paired with another term coming from the corresponding swapped rearranging, and those 2 rearrangings have opposite signs. So the entire sum changes sign. Therefore alt of t is alternating. In short, the construction was specifically designed to be moody about swaps, and it performs exactly to specification. Finally, if t is already alternating, then alt of t equals t. Indeed, rearranging the inputs by sigma multiplies t by sign sigma. Plug that into the formula for alt, and every term becomes sign sigma squared times t of v1 through vm. Since sign sigma squared is always 1, all m factorial terms are just copies of t. So the factor 1 over m factorial cancels them. Miraculously, the normalization was not pointless. So alt is a projection from multilinear functions onto alternating multilinear functions. In the bilinear case it extracts the antisymmetric part. And more importantly for us, this is the basic tool behind wedge products and differential forms. Yes. The innocent-looking averaging formula is secretly opening the door to a much larger world. Next we will build a generalized 3D cross-product using alternating multilinear ideas. After that, we will preview differential forms. So today was the technical preparation. The prettier geometry is coming soon. Because apparently even symbol-heavy suffering is occasionally rewarded.